So now that we've taken care of bases that are numbers like 13, 15, 3, we need to look at a special base, which is called base E. All right, and so this is our rule for base E. E is a number, and if you look on your calculator, all right, anytime you take a number and you raise it to the first power, it gives you that number back again. So I can do the same thing with E. The only difference is that you have to find it on your calculator. So it's the one that you usually have to use a shift button for. All right, so if I take E to the first power, so this is approximately, 2.71828, and it continues on with that pattern, 1828 forever. It's almost like the pi symbol. So it is a number. Even though it's written as a variable, it's a number, just like using the pi symbol. Right? And so with base E, you have your own types of rules. Right? And so, again, we are going to do the same strategy. You're still going to take and isolate e to the x, or e to an exponent, equals your base. And when you take the ln of both sides, right, and you bring this exponent out front, right, there's a very special property with ln and e right here. So once you've brought the exponent out front as a factor, ln and e are considered inverses of each other. All right? And so what they do is when you just have this, no exponents, no extra numbers, ln and e cancel each other out. It's like having 1/4 times 4. They're inverses, so they just become the factor of 1. And so the value for x will be just what happens when I use the ln of b. Right? So it's the same process, except that ln and e, you're not going to divide both sides by that because they cancel each other out. So that's my new rule. All right? And it only works with base e to have that canceling aspect. So let's just look at a couple examples. So 2e to the negative 3x equals 8. And again, you need to isolate your e to the exponent, which means I need to divide both sides here by 4. Or sorry, by 2 to get 4. And now I can use my rule or my property. So the ln of e to the negative 3x equals the ln of 4. All right, so when all of this gets brought out front, I end up with the negative of 3x equals the ln of 4. So again, I'm going to bring it out front, and when I do that, these are also simplifying at the same time. So to find x in my calculator, I need the ln of 4 divided by negative 3. And again, that is an exact value, but I need to approximate today to 4 decimals. So the ln of 4 divided by negative 3. Oops. And so that's going to be a negative. And again, 0.4621 is how this is going to round. Probably the ones that look more complicated, that have a lot more work. All right, we'll do one that has multiple operations happening. So again, sometimes it's good to be able to highlight what your base and your power is to see, what do you have to get rid of. So in terms of order of operations, I need to add before I can divide. And so that's what I'm going to do, is I'm going to add 10 first. All right, and that's going to give me a negative 5 over here. And then I need to divide both sides by negative 3. And again, because that's not a nice terminating decimal or a nice integer value, I need to leave it alone. So again, taking the ln of the left and the ln of the right is going to bring this entire exponent out front. And I get 6x plus 1 equals the ln of 5/3. And again, now I have more operations that I need to complete to be able to isolate x again. All right, so I'm going to subtract 1. and then I need to divide by 6. And so you really need to perform all of these operations very specifically, right, and show all of your step-by-step. All right, so the ln of 5/3 minus 1, all of that is happening in the numerator, and then I can divide by 6. So I get negative 0.0815. Okay. So take your time. Don't try to go too fast, but you need to show all of your steps and approximate correctly.